Hey guys, welcome back. Today we're going to be talking about factoring out a greatest common factor, and I'll teach you what that is in a second. But just so you know, we usually call that the GCF, and that's what that stands for, greatest common factor. Alright, so let's get started. Before I jump right in and show you how to take out a greatest common factor, let's just review the basic distributive property. So just the regular distributive property is that the number on the outside getting multiplied goes to both. So if I do this first example, that would be 2x plus 10. The 2 is getting multiplied to both the x and the 5. Alright, let's do the next one. Negative 3, if I multiply that to both terms, that gives me negative 3x. And then remember here, a negative times a negative is a positive. So that gives me negative 3x plus 12. Okay, let's do the next one. 4x, that whole thing has to get multiplied to both of these. So the first one might look weird, like what's 4x times x? How do we do that? Well, remember the exponent on here is technically 1, and the rule is that if they have the same bases, which they both do, then you add the exponents. So this would just be, and as far as this 4 in front goes, if it helps you to think about this one technically being a 1x, just so you know that you're multiplying 4 times 1, sometimes that helps kids. So that would be, the 4 times 1 part gives me 4, and then the x times x, if you add the exponents, 1 plus 1 would be 2, so that would be 4x squared. 4x squared. Okay, so let me just erase that and write that now. So we know that doing this first part, 4x times x is 4x squared. And 4x times negative 2 is negative 8x. Okay, and then let's do this last one. 5a times b, what would that look like? Well, that would just be 5ab. Everything multiplied together, all in one term. The a and b can't combine. I can't add exponents or anything because these are different letters, so there's no exponent rule that can be applied to this. And then for the second part, taking 5a and multiplying it by 6, that would give me 30a. Okay, so that's how just the regular distributive property goes that we already know. And let's go backwards. So when we say we're learning how to factor, what that means is we are undistributing. So something has already been distributed in, and we are going to find what that was and take it out. Take it out and write it out in front. Just like these ones looked, how there was a number out in front. That's what we want to do, is take a number, pull it out to the front. So what we want to do, step 1, is you need to find the greatest common factor. And what that means is what's the biggest number that goes into both of these things? It has to go into both. Okay, so let's think about that. Well, when I look at 3 and I look at 12, I know that they both divide by 3. And there's nothing higher. 12 divides by higher things like 6, but 3 does not. So you have to take the highest one from both of them. And the highest one here would be 3. So 3 is the greatest common factor. I'm going to write that on the outside. And what that means is we're actually dividing both of them by 3. So 3x divided by 3, the 3's would just cancel, and all you would have left is x. And 12 divided by 3, that's 4. So when I undistribute, if I take out a 3 from both of these things, let me erase this and write it neater. So I took out a 3 from both terms. What we're saying is that what's left is x plus 4 in parentheses. Now, if you want to check that you got the right thing, you could always just distribute it back in. 3 times x is 3x, and 3 times 4 is 12. Does that match the original problem up here? Yes, so I know that I did it right. So again, undistributing, which is called factoring, all we're going to do is take out the biggest number that we can from both of these, write it on the outside, and divide what's left. All right, let's try that again. So in the next one I have negative 7x and 28. So if there is a negative, you do want to take that one out as well. So what's the highest number that negative 7 and 28 both divide? Well, that would just be negative 7, because negative 7 definitely divides by itself, and 28 also divides by negative 7. In fact, what is that? 28 divided by negative 7 gives us negative 4. So let's just keep that in mind. I'll write that down in a second. Alright, so let's do that. Let's take out the negative 7 from both terms. And again, when I mean take out, what you're technically doing is dividing both of these by negative 7. Since when you distribute, you're multiplying, it should make sense that when you take it out, you're dividing. Okay, so what would be left? Negative 7 divided by negative 7 is x, And 28 divided by negative 7, we already talked about that being negative 4. So my final answer is negative 7 times, in parentheses, x minus 4. Again, if we want to check it, just distribute it back out. Go backwards again. Negative 7 times x is negative 7x, and negative 7 times negative 4, negative times a negative is a positive. Does that match my original problem up here? Yes, so I know I must have factored correctly. Okay, let's do the next one. This time I have more than just numbers. I also have letters in both of them. The reason I didn't talk about this earlier is because in the last example there was only a letter in this one and not in this one, so we didn't really have to worry about it. Now that there's a letter in both of them, we do want to think about how many letters we could take out. Okay, but before we get ahead of ourselves, let's just think about the number. What number can you divide 2 by and 12 by? Well, that would be 2. You can divide 2 by 2, and you can divide 12 by 2. And then the other thing you want to think about is over here we have 2 x's, and over here we have 1 x. So what would be the most amount of x's I can take out of both? Remember, it has to come out of both. Well, since this one only has 1 to give, I can only take 1 out. I can't take out 2 because there are not 2 x's on this side. So I can take out 2x. And what would be left when I do that? So again, what that means when I say take out is we're dividing. So if I divide this by 2x, 2x squared divided by 2x. Another way of writing that is 2 times x divided by 2x. Those cancel, and the only thing that's left is 1x. So that would be x, or 1x. And the next part is what's 12x divided by 2x? Well, the x's cancel, and 12 divided by 2 is 6, so positive 6. So my final answer is 2x times, parentheses, x plus 6. Again, if I want to check that, distribute that back out. 2x times x is 2x squared, and 2x times 6 is 12x. Does that match the original problem? Yes, so we're good. All right, and let's do the last one. When I just look at the numbers alone, I have 10 and 5. What number can I divide both of these by? Would be 5, because 10 divides by 5 and 5 divides by 5. So let's start, let me give myself more room. Let's start by taking out a 5 from both terms. And now let's look at the letters. The first one has an A and a B. The second one only has an A. Well, since this one doesn't have a B, I can't take out a B from it because there is none. So the only letter I can take out from both would be an A. Okay, so what do I get when I do that? Let's divide this part by 5A, and 10 divided by 5 gives me 2. The A and A would cancel, and the B is still there. So 2B is what I have left. And let's do the second part. 5A divided by 5A, everything cancels, and that would just be the number 1. Anything divided by itself, remember, is the number 1. So my final answer is, let me write that a little more neatly, 5A times 2B plus 1. And lastly, remember, if we want to check it, just distribute it back out and double check that it matches the original. So 5A times 2B would be 10AB, and 5A times 1 is 5A. Does that match the original up here? Yes, so I know I had the right answer. Again, so this process where we find the greatest common factor and take it out is called factoring out a GCF, which stands for greatest common factor. We say greatest because it's the biggest possible thing that can come out. We say common because it has to come out of all the terms, not just one of them or two of them. And factor because we are technically dividing it out of everything. Alright, so let's keep practicing. I have all the steps written over here for you if you get stuck or need to look, because for a few of these I'm going to have you pause and try it on your own. Let me do the first one with you, and then I'll have you pause and I'll tell you exactly which ones I want to try you do on your own. So first thing is I need to, looking over here at step 1, find the GCF of the coefficients. The coefficients are just the numbers. So let's look at just the numbers. 5 and 15, what can I divide both 5 and 15 by? Well, that would be 5. So I found that. And the second part of step 1 says then find the GCF of the variables. So that means the letters. So let's look at the letters in this. I have x squared and x. In other words, I have 2 x's here and 1 x here. How many can I take out of both? Remember, it has to come out of both. Would only be 1, because there's only 1 over here. You can't take 2 out of that. So I can take out 1x, so I'll put a 1x next to it. Okay, so step 1 is done. I found the GCF, and actually step 2 is done too. I wrote it on the outside. Maybe I'll put parentheses here just to really show that it's on the outside. And step 3 says divide each term by the GCF. So now I will think, okay, what is 5x squared, I'll write it over here, divided by the GCF, which is 5x. Okay, so again, in your head you should be thinking 5x squared is 5 times x, and I'm dividing that by 5x. So the 5's cancel, one of the x's cancel, and what's left is just 1x. So I'll write that down. 1x is left. Now let's do the same thing but divide it with the 15x, and I'm going to do this down here. 15x divided by 5x, the x's cancel, and 15 divided by 5 is 3. So now I will write plus 3. And that's it. I have factored now. I factored using a GCF, and I'm done. I could always check it by distributing it back and just making sure. So let's do that. 5x times x is 5x squared, and 5x times 3 is 15x. Does that match the original? Yes. Okay, so I just want to point out, that's not actually the answer. That is just checking our work. The only part that's the answer is this right here. Taking out the GCF and then writing what's left, this is the part that'll be our answer, our final answer. Okay, actually, let me do one more with you guys before I have you try some on your own. Let's do this one down here. Alright, so again, step 1, find the GCF of the coefficients. So look at the numbers, 7 and 12. And what we have to ask ourselves is there a number where 7 divides by that number and 12 also divides by that number? And for these that we've been doing, dividing by numbers, if you guys are struggling with that, you can always type these into your calculator. So for instance, like if I wasn't sure about factors of 7, I can literally type on my calculator, 7 divided by 2. Do I get a whole number or do I get a decimal? And for that, if you type that in, you will get a decimal, so that's not going to work. 7 does not divide by 2. And just keep testing it. Does 7 divide, oop, that's a funky division sign. Does 7 divide by 3? No, you're going to get a decimal for that. Does 7 divide by 4? No. Does 7 divide by 5? No. Does 7 divide by 6? No. Does 7 divide by 7? Well, of course it does. It's just going to be itself 7 times 1. But every single number will be itself times 1. So we can count that. We can think, okay, 7 times 1. And then do the exact same thing with the number 12. Go through the factors of 12. Does 12 divide by 7 or 1? I don't need to go through all the factors of 12 because remember they have to be common factors. So if it's not a factor of 7, then I can't count it for 12 either. So does 12 divide by 7? No, it doesn't. Does 12 divide by 1? Yeah, but dividing by 1 doesn't change anything, so that one doesn't really even count as a factor. So what we're noticing here is that 7 and 12 don't have any common factors. There's no number where I can divide that, do 7 divided by that and 12 divided by that. So there's no numbers I can take out. So step 1's done. There's nothing really I can take out. Well, I guess there's really nothing I can take out with numbers, but let's just double check that there's nothing that I can take out with the variables. So let's see, I have an x over here, I have a y over here. Those aren't even the same letters, so they definitely don't have anything in common, so I can't do anything. In fact, this one's just done. There's nothing I can divide out by both of these, nothing, so I'm done. Whenever that happens, we call it a prime factor. Okay. So now that I've done a couple of these examples, the ones I want you guys to try on your own is this one and this one. So pause the screen here, write these down on a blank piece of paper, give them a try, and then hit play when you're ready to check. Alright, so check your answers here. I'll kind of walk you through a few things. When I looked at the first one, I looked at the number 2 and 8 and noticed that I could divide both of them by 2. And then I looked at the letters. I had 3 x's here and 2 x's here, which means I can take out 2 of them. So I did that. And then I just divided both terms by 2x squared and wrote what I had left on the inside. Alright, and let's look at this one down here. When I looked at the number 15 and the number 10, I noticed that they both can divide by 5, so I wrote that number on the outside. Then I looked at the letters. This one has a letter and this one doesn't. So they definitely don't have any letters in common, so there's no letter I can take out. So then all I had to do was divide this by 5 and write that down, and divide -10 by 5 and write that down. And I'm done. All right, remember you can always check your answers by just redistributing it back and making sure that it matches the original problem. Okay, I'm going to clear my screen. We'll do this one down here together, and then we will move on. So the last one, I have 3 terms now instead of 2. That doesn't make it any more complicated. I just have to look and make sure that the number and the letters that I choose can come out of all 3 instead of just 2. Okay, let's start with the numbers like always. I have 15, 5, and 30. So what's the highest number that I can divide all 3 of those by? Well, I'm thinking it would be 5. I definitely can't take anything greater than 5 out of that middle term since it is the number 5. And 15 divides by 5, and so does 30. So as far as the number goes, all of these can be divided by 5, so I'll write that down. Now let's figure out the letters. Let's start with the X's. 3 of them here, 2 of them here, and 1 of them here. So how many can I take out? Well, only 1, because this one only has 1. If you tried to take out any more, there is no more over there. So 1 is the most amount of X's I can take out from all of them. And let's look at the Y's. I have 2 here, 1 here, 1 here. What's the most I can take out from each of them would be 1, because this term here and this term here only has 1 to give, so I can't take out any more. So I will write a Y down. Okay, and now I found my GCF. Step 1 is done. I wrote it on the outside. Step 2 is done. So now let's do step 3, where I take the GCF and divide it by each term. So let's do the first term. What is 15x cubed y squared divided by 5xy? Well, 15 divided by 5 is 3. X cubed divided by x, remember subtract the exponents. This technically has an exponent of 1. 3 minus 1 is 2, so that'd be x squared. And x squared divided by, or y squared divided by y. Remember, exponent of 1, subtract the exponents, would just be y. Okay, let's do the next one. Negative 5x squared divided by 5xy. Well, the negative 5 divided by 5 gives me negative 1. X squared divided by x gives me x. And y divided by y gives me 1. So I don't need to write that one down because that's just going to be a 1. And last one, 30xy, I'll write this one down, 30xy divided by 5xy. Well, the x and the y will cancel, and I have 30 divided by 5, which is 6, so plus 6. Okay, and I am done. So down here, this would be my final answer. So you can see I didn't do anything new. It wasn't like there was any new math. I just had to check that it worked for 3 terms instead of just 2. If you need to look this over to check anything, pause the screen here now before I move on. Alright, so here's some more examples. If you're getting a little bit confused, don't worry. We're going to be doing plenty more examples. And if you are feeling like you're getting the hang of it, don't worry too, because I'll start going through them faster. Okay, so number 1, let's look at it. 3 and 12. Can I divide those by anything? If so, what's the biggest number? Yes, I can divide both of those by 3. This one has an x and this one doesn't, so I can't take a letter out because there is no letter in the second part. So 3 is my GCF. What's left when I divide that? 3x divided by 3 is x, and 12 divided by 3 is 4. And I'm done. Again, if you want to check, distribute it back and make sure that it works to be the same as the original. Okay, number 2. Look at the numbers, 7 and 7. What can both those divide by? 7. And let's make sure, before I actually write my parentheses, is there a letter that can come out of both? Well, this one has a y and this one doesn't. So since the second one doesn't have any letters, there's definitely no letters I can take out. So my GCF is just 7. 7y divided by 7 gives me y, and 7 divided by 7, it's actually negative 7, would be negative 1. And I'm done. Okay, let's move on to the next one. Let's look at actually let me clear my screen. Let's look at just the numbers. I have 8 and 36. What is the highest number that I can divide? And it can do 8 divided by that number and 36 divided by that number. Off the top of my head right now, I'm thinking 4, because I know 8 divides by 4 and 36 also divides by 4. Again, if you didn't know that, you could just guess and check on your calculator until you get something that works. So when you type that in, 36 divided by 4 gives us 9. So this is where knowing your multiplication facts are going to be really, really helpful. And if you kind of need to brush up on those, I'd highly recommend doing that because otherwise it's going to take you a long time to come up with those common factors. So 8 can divide by 4 and 36 can also divide by 4 and nothing higher. So I'll write that number down. And then let's look at the letters. This one's an M, this one's an N. They're two completely separate letters. They have nothing in common. There's nothing I can take out. So my GCF is just going to be 4. And now I will take that and divide my GCF by both of those. And I'm really just kind of, I don't actually write that down every time. That's just what you should be thinking in your head. So let's divide them both by 4. 8M divided by 4 gives me 2M. And 36N divided by 4 gives me 9N. And I'm done. Again, if we want to check, always distribute it back out and make sure that it matches to be the original. Alright, let's look at our next one. I actually have no numbers in here, so I don't need to think through any factors. I just need to think about how many letters can I take out of both of these. Well, they both have an A, just one. This one doesn't have a B, so I definitely can't take a B out from both of them. So I'll take an A out, and what's left? Well, the first one divided by A, the A would just go away, so you'd have B. And the second one, you have negative A divided by A would be negative 1. Again, if you need to check it, distribute it back out. A times B is AB, A times negative 1 is negative A, and that matches the original. Okay, at any point, if you need to kind of pause and check over this or think through some numbers in your head, definitely feel free to do that. Alright, let's move on to the next one. Looking at just the numbers, I have 6 and 27. What is the greatest common factor that can come out of both of those? Again, this is where multiplication facts are really, really helpful. So I know 27 does not divide by 6, but I am thinking right now, well, 6 divides by 3, and 27 also divides by 3. So let's take a 3 out from both of those. And I'm not saving any space to write a letter because I'm noticing that this one doesn't even have a letter, so I definitely can't take a letter out. So what is 6a squared divided by 3? Well, that would be 2a squared. And what is 27 divided by 3? That would be 9. And I'm done. I've undistributed. I'm good to go. And the last one. Well, right off the bat, I see that 5 and 13, they have no common factors. There's nothing I can divide 5 by that would also divide by 13. And they're both prime numbers, so that's an easy one to think about. And then when I look at the letters, X and Y, those aren't the same letters, so I definitely can't take anything out from those either. So this one's already done. This is a prime factor. There's nothing I can do, nothing I can undistribute it from it. Alright, this is the last page we're going to do, and I want you guys to actually just pause right now and look at these 4 and reflect personally on if you feel 100% confident that you could do these last 4 on your own. If you feel totally confident looking at these 4 that you could do these all with no help at all, then you can skip to the end of the video and check your answers. If looking at these 4 you have some questions about like how to take things out with like exponents and you're still a little unclear on that, or when you have multiple letters like this, then obviously keep on listening and I will walk you through all of these to make sure that you're good to go by the end of this video. Alright, so let me give you a second to pause, look at these 4, and make that decision. Okay, so let's start with the first one. I don't have a number here. I mean, technically you can think about that you have the number 1, but like I mentioned earlier, it does absolutely nothing to undistribute the number 1. It won't change anything. So you can kind of think about it as like there's no number here, and on this one there's a number 3. Well, since there's not a number on the first one, I won't be taking out a number at all, since it can't come out of both. Okay, so now I just have to look at the letters. I have 2 X's here, I have 1 X here. That means I can take out 1 X from both of them. This one only has 1 X, so that's why I'm only taking out 1. Okay, so now let's look at the Y's. I have 1 Y here and 1 Y here. So how many can I take out of each of these terms? 1. Okay, so what would be left? If I have 2 X's and I'm taking out 1, how many is left? 1. If I have Y and I'm taking out 1, how many is left? None. Another way of thinking about it is X squared times Y divided by XY. The Y's cancel, and this just gives you X, which is why I wrote that as X over here. Okay, and now let's divide the second term. 3xy divided by xy. The x's and y's cancel, and all I have left is 3. So that's going to be my final answer, is xy times x plus 3. And again, if we were to take this and distribute it to both, we would get exactly what we started the problem off with, which means we definitely did it correctly. Okay, let's do the second one. When I look at the numbers 15 and 30, they both can divide 15. So that's the number, the biggest number that can come out of both of those. And now let's look at the letters. I have a squared, so I have 2 a's and 1 a over here, which means I can take out 1 a for both of them. And lastly, let's look at the letter b. I have 1 here and 1 here, which means I can definitely take out 1 of each. And what would be left? So if I were to divide this by both factors, for the first term, I would have, well, let's see, 15 divided by 15 is 1, so I don't have a number left. A squared divided by a is a, and b divided by b, that would just cancel out, or you can think about giving it as the number 1, which we don't need to write. Okay, and let's do the next one, which is negative 30ab divided by our GCF 15ab. Negative 30 divided by 15 is negative 2. A divided by A is 1, and B divided by B is 1. I don't need to write those in, so I don't. And so that's my final answer, actually. 15AB times parentheses A minus 2. All right. And let's look at the third one. The numbers I have 6, 14, and 10. So what number can come out of both of these? Well, factors of 6 are 3 and 2. For 14... let's see, 14 doesn't divide by 3, but it does divide by 2, so that one's working so far. And 10 also divides by 2. So as far as the numbers go, 6, 14, and 10, I can take out a 2 from all of those. And then let's look at the letters. I have 4 y's here, 3 here, and 2 here. That means I can take out 2 from all of them. And what would be left? Well, 6 divided by 2 is 3. Y to the 4th divided by y squared is y squared. And my next term, 14 divided by 2 is 7. Y cubed, so this, y cubed divided by y squared is y. And I'm done with that term. Last term, negative 10. Let's just do the number. Negative 10 divided by 2 would be negative 5. And y squared divided by y squared, those would just cancel. And so that would be my final answer. Okay. Last one, let's look at the number 18 and 48. So factors of 18, what would those be? Well, let's see, it's 6 times 3, also 9 times 2. And does 48 divide by any of those? Well, let's start with the biggest one, because remember we want the greatest common factor. Can 48 divide by 9? And 48 does not divide by 9. So let's move on to the next biggest number of this list, which is 6. Does 48 divide by 6? Yes, that'd be 8. So I know that's my answer. Since 18 divides by 6 and 48 divides by 6, that's the biggest number I can take out of both of them. So let's do that. So I'll write a 6 down. And then let's look at the the letters. I have a squared and a. So I can take out an a from both of those. Next I have b and b. That means I can take out a b. And lastly I have c squared and c cubed, which means I can take out a c squared. Okay, so what would be left? 18, starting with this first term, 18 divided by 6 is 3. A squared divided by a is a. B divided by b is just 1, so nothing. And c squared divided by c squared, again, is just 1, so nothing. And let's do the next factor. Negative 48 divided by 6 is negative 8. A divided by a is 1, so nothing. B divided by b is 1, so nothing. And c cubed divided by c squared would be c. So this is my final answer, and I'm done. Alright, that's it for today, you guys. Good job. If you understand how to take out a GCF, then you are good to go, and that is the main goal for today, is that you can factor by a GCF. If you get stuck, you can always go back to this slide where I have all the steps written out for you over here in this box. Have a great day, and remember, you can always check in during office hours to ask me for questions.